soccer is the infamous penalty kick. And in this investigation, we're going to find the velocity of an average penalty taken from the game's most feared striker. We're also going to find the kinetic energy produced from one of these kicks by using the equation kinetic energy equals 1/2 mass velocity squared. I know that kick probably went so fast you couldn't even see it, but our experts back at the lab dissected the kick from a physics standpoint, and we found that using the equation distance over time, the ball actually went 2.8 meters per second. Then, using the equation kinetic energy equals 1/2 mv squared, we found that the ball had 2.83 joules of kinetic energy with it. Enough to take your head off.
Today, we're going to take a look at the physics of headers in pink soccer, one of the most important shots. Giving you your lesson today will be the 2014 season runner-up, Sam Prescott. So, the header is one of the most important shots in the game. So, of course, when you want to aim your header, you've got to pay close attention to the gravitational potential energy of the ball when it's at the top of its arc. Check this out. How much gravitational potential energy did that ball have? Let's find out. So how do we find the change in gravitational potential energy of that ball? Let's find out. So the equation for change in gravitational energy is delta UG, gravitational energy, potential energy that is, equals mass of the ball times little g, 9.81, times delta y, the change in the height of the ball. Based on our mass of 0.68 kilograms, our g of 9.81, and our change of height of 1.83 meters, we determined that the change in gravitational potential energy of the ball from my hand to the top of its arc is 24.4 joules. We're now going to take a look at the PK revisited. I consider myself more of a finesse player, so I take somewhat slower penalty kicks, so our velocity is going to be different, but what we're doing here is we're determining the amount of momentum that the ball picks up on its way to the goal. Let's see how this goes. Hey, want to find out how we got the momentum of that ball? Awesome. You're about to find out. So we use the equation momentum equals mass times velocity. We already determined that the mass of the soccer ball is 0.68 kilograms. So, by using the equation distance over time, we determined that the velocity of the ball is something that I did not write down. You can start this over. Hey, you want to find out how we're going to get the momentum of that ball? Today's your lucky day. So the momentum equation is P equals mv. Momentum equals mass times velocity. We already determined that the mass of the ball was 0.68 seconds. So to determine the velocity, we used distance over time. The distance was 3 meters, and the time was 3.26 seconds, so our velocity was 0.92 meters per second. So by multiplying 0.92 meters per second times 0.68 kilograms, we got 0.626 kilogram meter seconds as our momentum. There you have
it. Mickey on the track.
Baby.
720 McTwisty.
Baby, won't you come